Prepare to witness an automotive revolution that could send shockwaves through the electric vehicle industry. Toyota's CEO has unveiled a game-changing engine that threatens to disrupt the EV dominance as the world races toward electrification. Could this innovation derail the EV revolution? Are we on the brink of a seismic shift in the automotive landscape, or is this just another bold claim in the competitive world of car manufacturing? Let's explore the evolution of Toyota's engine technology. As Toyota stands on the precipice of a new era in automotive technology, its journey is nothing short of remarkable. From humble beginnings to the cusp of revolutionizing the industry, Toyota's evolution in engine technology is a testament to innovation, perseverance, and foresight. In the earliest days, Toyota's foray into engine development was characterized by engines that were simple yet effective for the times. But did you know that during World War II, Toyota primarily manufactured standard-sized trucks almost exclusively for the Army? This period was crucial for Toyota, laying the foundation for its future in automotive engineering. Post-war, Toyota began to diversify and refine its engine technology. The company's venture into gasoline engines marked the beginning of a journey toward more complex and efficient designs. In the 1950s and 1960s, Toyota introduced engines like the R-Series, which were notable for their durability and reliability. These engines powered some of Toyota's earliest successful cars, setting a standard for the brand's commitment to quality. Fast forward to the 1990s and early 2000s, a period marked by significant advancements. Toyota introduced the 7AFE lean burn engine, which was a pioneering effort in reducing emissions. The development of the variable valve timing intelligent mechanism, and engines like the 2JZG represented a big leap in both fuel efficiency and performance. Then the turn of the millennium saw Toyota delve into hybrid technology, with the development of the 1NZ-FXE, the world's first engine for gasoline-electric hybrid vehicles. These innovations underscored Toyota's commitment to environmental sustainability long before it became a global trend. In the past decade, Toyota has not only continued this legacy, but has significantly accelerated it. The introduction of the dynamic force engine family brought engines that delivered exceptional fuel efficiency without compromising performance. This engine family, powering models like the Corolla and Camry, showcases Toyota's ability to combine fuel efficiency with performance, a feat that's not easily achieved in the automotive world. But what about the present? As we stand in 2024, Toyota is on the verge of a breakthrough that could redefine the automotive landscape. The company's latest endeavors in hydrogen-powered internal combustion engines and the development of water-powered engines represent a bold departure from conventional automotive powertrains. These technologies are radical reimaginings of what powers our vehicles. Think about it, an engine that emits only water vapor, harnessing the most abundant element in the universe, hydrogen. The implications are staggering. This isn't just about reducing emissions or improving efficiency, it's about completely rethinking how vehicles impact our planet. While the mystery that surrounds these new technologies only adds to their allure, how will these engines perform in real-world conditions? What will it be like to drive a car powered by water? The answers to these questions could very well change our entire understanding of what it means to drive. As we anticipate Toyota's next big reveal, one thing is certain: the automotive industry is on the brink of a revolution, and Toyota is leading the charge. Toyota's hydrogen-powered internal combustion engines. In a world where electric vehicles are increasingly becoming the norm, Toyota's foray into hydrogen-powered internal combustion engines emerges as a game-changer. But what exactly sets this technology apart from the traditional gasoline engines in electric vehicles we've become accustomed to? The crux of Toyota's innovation lies in the use of hydrogen as a fuel for combustion engines. But why hydrogen, and how does it work in an internal combustion engine? Unlike hydrogen fuel cell electric vehicles like the Toyota Mirai, which generate electricity through a chemical reaction, hydrogen internal combustion engines, or H2 burn hydrogen directly in a manner akin to gasoline engines. This direct combustion method has a unique advantage. It produces almost zero carbon dioxide emissions. The only significant byproducts are trace amounts of engine oil burned during driving and some nitrogen oxides, due to the intake of oxygen from the air. However, these emissions are considerably lower compared to traditional internal combustion engines. Have you ever considered the performance capabilities of an engine running on hydrogen? Well, the answer really lies in the engine's design. Toyota modified its 1.6-liter turbocharged three-cylinder engine, which you might know from models like the GR Yaris and GR Corolla, to accommodate hydrogen fuel. This included the integration of a robust fuel tank for high-pressure hydrogen storage, along with a re-engineered fuel supply and injection system. Interestingly, hydrogen combustion occurs faster than petrol, which actually offers the potential for a highly responsive engine, a trait that's particularly beneficial in motorsport applications. But what about the real-world applications of such an engine? Toyota has been really proactive in testing and refining this technology in the demanding environment of motorsports. The Corolla Sport race car, equipped with a hydrogen-powered G16E GTS race engine, has demonstrated some pretty impressive performance metrics. Lastly, what is Toyota's ultimate goal with this technology? It's not just about creating a new type of engine. It's about, envisioning a sustainable future. Toyota aims to achieve carbon neutrality by 2050 and sees hydrogen combustion engines as a crucial step in this direction. The company's commitment goes beyond just automotive applications, encompassing collaborations to address challenges in green hydrogen production and infrastructure development. This multifaceted approach really underlines Toyota's belief in the potential of hydrogen as a key element in the transition to a carbon-neutral society. So, by combining the familiarity of traditional engine designs with the environmental benefits of hydrogen, Toyota is not just challenging the current EV-centric narrative, but is also redefining what sustainable transportation can look like. As the automotive world pivots towards sustainable technology, Toyota's hydrogen-powered internal combustion engines present a fascinating proposition. But how exactly do these engines stack up environmentally, especially when compared to hybrid electric vehicles and plug-in hybrid electric vehicles? Let's delve into this question and unravel the environmental benefits of hydrogen engines. Firstly, what makes hydrogen engines stand out in terms of environmental impact? The key factor here is their emission profile. Unlike traditional gasoline engines, which emit a significant amount of carbon dioxide, a greenhouse gas contributing to global warming, Toyota's hydrogen engines produce zero CO2 emissions during operation. The primary emission from these engines is water vapor, making them an incredibly clean alternative in terms of greenhouse gas emissions. But, is it really possible to have an engine with such minimal environmental impact? Yes, it is. The secret lies in the combustion process of hydrogen engines. When hydrogen fuel is burned in these engines, it reacts with oxygen from the air to produce energy with water, vapor being the only byproduct. This process starkly contrasts with the combustion of fossil fuels, where carbon in the fuel combines with oxygen to produce CO2. The elimination of CO2 emissions from the tailpipe is a significant step towards reducing the automotive industry's environmental footprint. But how does this compare to HEVs and PHEVs? HEVs, which combine a gasoline engine with an electric motor, and PHEVs, which can be plugged in to charge their batteries, offer improved fuel efficiency and reduced emissions compared to conventional gasoline vehicles. However, they still rely on gasoline and therefore produce CO2 emissions during operation, albeit at lower levels than traditional vehicles. In contrast, hydrogen engines offer the potential for true zero-emission driving as long as the hydrogen fuel is sourced sustainably. Another environmental aspect to consider is the life cycle emissions of these vehicles. While hybrid electric vehicles and plug-in hybrid electric vehicles have batteries that require rare earth elements and often involve energy-intensive manufacturing processes, hydrogen engines avoid these challenges. The production of hydrogen fuel, especially when derived from renewable sources like wind or solar power, can be less environmentally taxing than battery production, offering a more sustainable overall life cycle. A question that naturally arises at the forefront of this automotive evolution is how Toyota engineers have managed to preserve the visceral performance and responsive power characteristic of a traditional internal combustion engine, while transitioning to a fuel source with fundamentally different properties. The answer lies not in a single component, but in a meticulously engineered symphony of systems centered around the unique hydrogen combustion process. Hydrogen, as a molecule, possesses a high energy content by mass, but its low density and vastly different combustion characteristics, such as a high flame speed and a wide range of flammability, present both an opportunity and a challenge. The cornerstone of this adaptation is the advanced high-pressure hydrogen direct injection system. This represents a significant departure from conventional port fuel injection or even modern gasoline direct injection systems. In a traditional engine, fuel is introduced into the intake airstream or cylinder at relatively low pressures. For hydrogen, this would be inefficient and potentially dangerous, as the gaseous fuel could prematurely mix with air in the intake manifold. Instead, Toyota's system injects hydrogen directly into the combustion chamber at extremely high pressures, much like in a modern diesel engine, but tailored for a gaseous fuel. But how does this impact the engine's overall performance? Remarkably, the 1.6-liter engine manages to deliver power and torque figures that are competitive with its gasoline-fueled counterparts. The turbocharger plays a vital role in this, ensuring that the engine delivers the necessary boost for high performance. But is turbocharging enough to handle the unique properties of hydrogen? The challenge with hydrogen is its low density compared to gasoline. This characteristic necessitates a larger volume of hydrogen to achieve the same energy output as gasoline. Toyota's engineers have tackled this challenge head-on, ensuring that the turbocharger and other engine components are optimized for hydrogen's specific